So we're looking at chapter 3.4, which is graphing the basic functions. And we kind of went over some of this in the last section, but I wanted to take the time to go over and show you again how to graph them. So hopefully you guys have your free version of the calculator. That's I put the instructions in the getting started module. You're going to need that a lot. Go to your calculator, press Y equals, enter X, and then square it and graph it. And you see the classic x squared function, which is a quadratic function. You can use the trace button to show you points on the graph. You can go left or go right. Or if you wanted to find a specific point on the graph, press second and the trace button and select number 1. And here you can type in specific points. For example, when x is equal to 2, y is equal to 4. And also when x is equal to -2, y is equal to 4. Which is the classic signs of an even function. Okay. So next we're going to speak about the absolute value function, which is f of x equal to the absolute value of x. So to see that, we would go to y equal again, clear it, press second and the 0 button to access the catalog, and select the first entry there, which is ABS, absolute. Enter your independent variable and close the absolute sign. Graph it. And as before, if you wanted to see points on this graph, you can simply press second, calculate, and let's say we entered x is equal to -2. We know that when we find the absolute value of -2, it becomes +2, and it shows you the point on the graph. Next, we're going to look at the constant function. So the constant function is a horizontal line passing through some point on the x-axis. In this case, I chose f of x equals to 5. And we're going to graph that with the calculator. So calculator, y equals, clear, and enter 5, and graph it. And we see that horizontal line. If you ran a trace anywhere on that line, no matter what x value you choose, the y value would always be equal to 5. Okay? Guys, the goal here is that you're able to recognize these functions without graphing them. So I'm just giving you the option to recognize them without graphing them. The next function is the identity function, the classic y is equal to x function. To graph that, we press y equals, clear, and type in the variable x. Graph it, and we see the classic graph that goes through the origin. You can run a trace at the point. You see when x is equal to 0, y is equal to 0. And you can also calculate any value. Now we know that if x is equal to 2, y will be equal to 2. If x is equal to -5, y will be equal to -5, because it's simply y is equal to x. And this is known as the identity function. Next, we're going to talk about the graph of the cube root function. The cube root function, f of x equal to cube root of x. Calculator. To access cube root, we press the math button and scroll down to number 4. Enter your independent variable and press the graph button. And this is the classic cube root graph. So for example, we know that the cube root of 8 is 2, so let's see if that works. Second, calculate the value when x is equal to 8. and we can see that the y value is equal to 2. Next, we're going to consider the graph of the cube function, which is y is equal to, or f of x is equal to x cubed. And notice the cube root function is sort of a flattened S. Now let's look at the cube function, which is x, the Dunscap button, and 3. And this is sort of a backwards turned S shape, and it's upright, and you can do a trace along it to see values related to x and y when x is equal to 1.3, y is equal to 2.54, and so on. Okay? The goal is that if you see a cube function, you should recognize it on demand. Okay. Now the square root function is y is equal to the square root of x. To get square root, we press second and the x squared button, type in your variable, and we see that we have the square function. You can see points along that line by running a trace anywhere along that line. Notice that since we cannot take the square root of a negative number, all of the x values here are positive. I want to also discuss a unique, different type of case here scenario. Uh, uh, if we have f of x equal to the square root of negative x, in this case, the x values would be less than or equal to 0. Okay, the domain of this function is less than. If we set negative x greater than or equal to 0, then positive x, we flip the inequality, is less than or equal to 0. So for example, if we wanted to find this, if x is equal to, say, any negative number, so let's say x is equal to negative 4, f of x will be equal to the negative of negative 4 square root, which will be equal to the square root of 4. Now, I want to show you what happens with this graph here. So if I were to, in place of x, change it to negative x and graph it, I will see that the graph is flipped backwards. And that's because now all of the x values are negative. For example, if I wanted to calculate this, the square root of negative 4, I would see that the y value is positive, because when we put it under the square root sign, the negative, because we're taking negative of x, negative and negative gives the square root of positive 4. So the y value will still be positive, but the x values are negative. Then we can talk about the reciprocal function, which is the function of 1 over x. Notice that x cannot equal to 0 because we're not allowed to divide by 0. Okay, so let's go ahead and plug this into our calculator. 1 divide x, and we see this graph. Notice this graph does not touch the x or the y axis. It just skims along it. Later on, when we talk about vertical and horizontal asymptotes, we're going to understand this a little bit more. If we were to type in x is equal to 0 here, we would get no y value, right? Because we can't divide by 0. But if I were to type in, say, negative 0.5, so 1 divided by negative half is equal to negative 2, and it shows the point on the graph right there. Okay. I also want to discuss the case with you that if I were to multiply this function by 36, if I go back here and I created a function where f of x is equal to 36 times 1 over x. This becomes 36 over x. What this does is that if you think about it, say when x is equal to 6, then the y value is 36 over 6, which is 6. So it creates a more spread out graph. So if I were to change 1 to 36 and graph it, your graph would look kind of like this now. And if I were to say check for when x is equal to 6, I would see that my y value is 6 and it's shown on the graph. Okay, the final type, this is a reasonably short chapter. The final type of function is called a piecewise function. And a piecewise function is comprised of more than one functions. Comprised of more than one functions. Now, if I were to provide you with an explanation, I wanted to also show you what the graph is. You can imagine that if a graph is comprised, say, of a square root and a straight line, then you'd have two different pieces on the graph, right? Here's y, here is x. We really don't need this bottom part, so I'll leave it out. And if I were to pick a couple of values, let's say, now what you have to visualize here is that to the left of 0 here on the number line means x is less than 0. And then to the right means x is greater than 0. And of course, in the middle, x is equal to 0. So if I were to pick numbers here, let's say I pick the numbers such as x is equal to -4, then I would need to substitute in the equation for x squared because in this particular case, x has to be less than 0, and x is a number that's less than 0, which is -4. So f -4 is equal to x squared, which is equal to -4 squared, which is equal to +16. Now, I can go ahead and mark that point. Let's say this is 4, this is -4, and here is +16. Okay, so I can mark my point on the graph. And you'll see where this is going in a second. Okay, now let's pick a point, say when x is equal to 0. And we're already told here that when x is equal to 0, the y value is -1. So f of x is equal to -1. So I can mark that point on the graph here as -1. And that would be a closed dot, wouldn't it? Now, things to consider here. If I wanted to pick a value, say x is equal to 2, that would be for the case of x greater than 0. So f2, I will be substituting in the 2x plus 1. So I'll be substituting 2 in here and getting 5. So there is a point at, say, 2 and 5. Now, I want you to consider a couple of things, right? The first scenario here is that we want to see, we know that x squared is a part of a parabola. And we want to consider what happens when x is equal to 0 in this case. For the parabola case, if x is equal to 0, f0 is equal to 0 squared, which is equal to 0. So that parabola ends right here. And there's half of that parabola in this case here that I'm going to sketch in, ends here. Okay, and that's my graph of f of x equal to x squared for x less than 0. Now let's talk about, we have an open dot here for the point, and let's talk about where this f of x plus 1, now this is for the case greater than 0, so we need to find out for x equal to 0 here. F0 is equal to 2 times 0 plus 1, which is equal to positive 1. So when x is equal to 0 for the straight line, y is equal to 1. And that, of course, would be an open dot as well. Okay, that's at 1. So this part of the graph is headed that way for all values greater than 0. And this is the graph of f of x equal to 2x plus 1 for x greater than 0. Okay. It is not recommended that you try to graph this a piecewise function with the calculator. Is just to understand how the graph works and how to find the points on it. There are long and detailed instructions available uh, on the internet if you want to try to graph it with your calculator. Okay, but I hope that you kind of understood what I was showing you with graphing this type of function. Okay, and that's all I have for you today with this.